And if you check my previous video catalog, I've dropped video on alkane and alkenes. So today we'll be looking at alkynes. What is alkynes? So if you have to take a look at these alkynes, we all know generally that for every alkynes, they are unsaturated hydrocarbon. And if you have to look at what unsaturated hydrocarbon entails, they contain carbon to carbon or molecule to molecule, either double bond or triple bond. But for these alkynes, we are only looking at the triple bond. So in a nutshell, we can say alkynes are unsaturated hydrocarbon that contain carbon-carbon triple bond. They also belong to homologous series. So now, if I have to take a look at this now, the first thing we are going to take a look at is unsaturated. The second one, we'll be looking at the homologous series. While the third one, let's take a look at what we call the sp hybridized. Exactly. So for this hydrocarbon, so looking at these three now, without these three, alkane's definition is not complete. And what do you mean by this unsaturated hydrocarbon? We can easily have this. So this triple bond is what we call a sigma bond. We have a pi bond. We also have a pi bond. So for every alkynes, for you to have this sigma bond, and pi bond here, we have to relate it back to what we call the sp hybridized, because we are having a sigma bond 1, pi bond we have 2. So in case you have been asked here as an undergraduate that how many pi bond and sigma bond does these alkynes contain? Alkyne contain 1 sigma bond and 2 pi bond. So if you have to take a look at this, the homologous series, they increase successively by we adding what we call CH2. With this, alkyne's general molecular formula is CnH2n minus 2. The n are either integers or we call them whole numbers. So for us to have these alkynes, we'll be replacing the ane from alkane with yne. So we need to take note of all this. So now let's take a look at the next one, which is the naming. Naming of alkynes. If you have to take a look at this naming of alkynes, we'll be starting with when n is equal to 2, because the first member of alkynes is when n is equal to 2, nothing like when n is equal to 1. It is wrong. So we can easily say that when naming alkynes, the general molecular formula must be obeyed, which is CnH2n minus 2. So now let's start. If n is equal to 2, using this formula here, so we can say C2H2, you open a bracket, you have to close it, minus 2. So 2 times 2 give us what? 4. You can say C2H4 minus 2. In that case, you can say we have C2H. 4 minus 2 give us what? 2. So the naming for this is called ethyne. That's the first member. The second one, n is equal to 3. You can say we have C3H 6. So the more reason why we say they belong to homologous series is that if you observe, for you to have this C3H6, it means we are going to add CH2 to this. So with that, you can say C plus C2 plus C1 will give us what? C3, and H2 plus this H2 here, we are going to have what? 4. So we can say C3H4 for propine. So if you are to add CH2 to this, we are going to have N is equal to 4, then we have C4H6. This is called butane. So the next one, when N is equal to 5, if you have C5H8, we're going to have what? Pentane. Then if you have N is equal to 6, C6H10, we are going to have hexane. So these are the naming of alkynes. Though we have other namings under this alkyne. After this hexane, we have heptane. Heptane. We have octane. We have nonine and decyne. So all these are the family of alkynes generally now. So now let's take a look at the structure. N is equal to 2. We all know this will give us what? C2H2. So we're having 2 carbon. Don't forget the functional group. So this is the structure of ethane. Then the second one, C3H4. So you can say you have 1, 2. So 1 hydrogen is there. 1, 2, 3. So if you are to write the molecular formula of this, the first thing we have here is CH3. We have C, triple bond. We also have what? CH. So this is our propine. So the next one is when N is equal to 4, we have C4H6. So we have 1, 2, 3, the triple bond, 1, 2, 3. So don't forget we're having 6. So 1, 2, 3, 4, 5. Then this will make it what? 6. So in a nutshell, for this we are having CH3. The second one is CH2, which is this. And we have C, triple bond. We have CH. This is named butane. So if we are given any compound under these alkynes, you need to look at the formula given to you before you can predict the structure. So now guys, let's take a look at the IUPAC nomenclature of some of alkenes naming. Look at the nomenclature. Let's see how we can easily name these alkenes. But note one thing, that anytime you have to name these alkenes, the first thing you need to consider is that the ending, that is where we replace our ane of alkane with ine, which is yne. And the second rules you need to understand under this nomenclature is that you must consider the longest carbon continuous chain chosen. So now we take a look at the nomenclature. So we have nomenclature. So the first one, if I have the CH3, CH2, C, I have C, then I have CH3. So according to what I just explained earlier, that we need to consider the longest carbon continuous chain here. So let's number from the, here is our left hand side, and here we have our right hand side. So like this, you can say that I have 1, I have 2, I have 3, I have 4, I have 5. From the left hand side here, 3 is attached to this functional group here. But if you consider it from the right hand side, you can say that I have 1, I have 2. We all know that if you are having 5, C 5 carbon is what? Pent. Pent. So 2 is attached to this carbon here, to the functional group. So if you are to name this, under this alkyne, 5 carbon is pent, so you can call it pentyne. And the 2 that is in between the functional group here will make you to name it as what? Pent. Because of the 2, we call it pentyne. That's the first name. The second one, if I have CH3, C8 attached with a substituent, we're having C, triple bond, C, we're having another substituent here, and we have CH3. Please and please don't forget the rules. The first thing you need to know is learn to consider both sides, the right hand side, the left hand side, as well as what? The right hand side. They consider the longest carbon continuous chain. If you look at this, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. We all know that 6 carbon, 6 carbon, carbon 6, we have X. So if you are to name a compound like this, let's go 1 from the left hand side, we have 2, 3, 4, 5, 6. It is obvious that even if you should consider the numbering from this right hand side, we'll be having the same thing. So the carbon attached to the functional group here is 3 from the left hand side. When we consider it from the what? Right hand side as well, you're having 3. So it means you can either pick the naming from both sides. So let's consider it from the left hand side. We have 1 and 2. 2 is attached to the substituent, and 5 is attached to the substituent. So if you have to name this compound, it is named 2,5-dimethyl X 3-ine. Again, 2,5 di, we're having 2, that's we call it identical. So di 2,5-dimethyl X 3-ine. So note one thing, that when it comes to this naming of either alkyne, alkene, irrespective of the group of organic compound you are naming, you need to be familiar with what we call the alkyl group. You can check that in one of my video catalog, which I explained under the IUPAC nomenclature of alkane, as well as the introduction to alkane, that explain more about alkyl. Exactly. So now let's take a look at some other compound. Again, how we can name the halogens with the alkyl. And one thing you should know about this is that for every halogen that is being considered or that is being attached to a carbon continuous chain with either alkyl group, we always give highest priority to the halogen, irrespective of the number attached to the halogen. So this example I'll be showing now, I will use that to explain what I just dropped now. So we have CH3, CH2, CH, you have a Cl, CH2, C, triple bond, we have a C, we have a CH, we have CH3 here, and we have CH3 here. So class, let's don't forget the left hand side. As a beginner, please always take note of this, the right hand side. So let's start the number from the left hand side. We have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8. 8 carbon atoms is octs. We all know it has under this give us what? Octane. Is that clear now? So the number attached to this here, this here is called the chloro. And we all know that our methyl CH3 is our methyl. So now, from the left hand side, let's consider the naming. You can say we have 3 chloro, 7 methyl, oct, 5 ine. So this is from the left hand side. Please don't forget the left hand side naming. So let's consider the naming from the right hand side now. So we have 1, 2, 3, 4, 5, 6, 7, 8. Now, it is very simple. The attached substituent to methyl here is 2. Then the carbon atom close to the functional group here is 3. But for this, we are having 5. While the other substituent attached, which is chloro, we are having 6 here. So that 6 chloro will come before 2 methyl. Why? Because in under organic chemistry, the alloalkane has highest priority than the alkyl group. So we can say we have 6 chloro, 2 methyl, oct, 3 ine. So this is the correct naming from the right hand side. Why this is wrong? Because majority of the students out there, they always name organic compound using the wrong approach. And when you use the wrong approach to name any organic compound, one thing about organic chemistry is that when calling it together, you feel like, what I'm naming is wrong. But when it comes to, if you follow the IUPAC nomenclature, that is the approaches to it, either from the alkane, the